Hey there, and welcome to This Explainer. Today, we're unpacking something absolutely mind-blowing. We're looking at a detailed, fact-based blueprint of how humanity plans to overcome literally some of the most insane logistical hurdles ever conceived to build a self-sustaining city on Mars by the year 2050. And look, this isn't science fiction, right? We're going to dig right into the exact engineering, the timelines, and the sheer grit required to cement our future as a multi-planet species. Okay, let's dive into this Martian survival checklist. We'll be moving step by step through the self-sustaining city, entering the robotic vanguard, manufacturing Martian rocket fuel, building the first habitats, and finally, farming on toxic soil.
Section 1. The self-sustaining Martian city, humanity's second home.
Now, to really understand the stakes of setting up this new home, we have to grasp the absolute necessity of being completely self-reliant. If this city can't survive on its own, it's basically doomed to fail. To put this into perspective, let's compare a moon colony to a Mars colony. A moon base is, well, it's essentially in our backyard. It's only about 1 day of travel time away, which means any resources they need from Earth are right within easy reach. Mars, on the other hand, is a completely different beast. With current technology, you're looking at up to 8 months of travel time one way. Even if future nuclear propulsion systems speed that up, the absolute best-case scenario is still a 45-day trip. So the crucial point is that a Martian city is completely isolated. The people there absolutely cannot depend on the resources of Earth. They've got to harvest every single thing the red planet has to offer.
And that brings us to this incredibly important number, 1 million. For this colony to be truly independent, there's going to come a day when the supply ships from Earth just stop coming. Whatever the reason, maybe it's economic, political, or, a disaster on our homeworld, Earth's support will eventually come to an end. To survive that exact moment, it's estimated that around 1 million people need to be living and thriving in this Martian city. We need incredibly deep roots there, both figuratively and literally.
But putting those roots down, that is going to be the most dangerous migration in human history. The surface of Mars is colder than Antarctica and drier than the Sahara, complete with massive dust storms. The atmosphere is so incredibly thin that liquid can't even exist on the surface. Without a pressure suit, a human being would instantly freeze, boil, and suffocate all at the exact same time. Add to that a colossal dose of nuclear radiation from the sun because there's barely any atmospheric shielding, and you quickly realize that Mars actively wants to destroy you.
Section 2. Enter the robotic vanguard. Optimus on Mars.
Because Martian conditions are instantly deadly, humans obviously can't be the first ones on the ground. We have to send autonomous robots to do the dirty, dangerous prep work. So, let's look at SpaceX's chronological roadmap for this. Optimistically, as early as 2026, 5 Starship landers will head to Mars, releasing a handful of autonomous, AI-powered humanoid robots, kind of like Tesla's Optimus, right into the landscape. Now, the initial goal is just to land without crashing. SpaceX is famous for learning through trial and error, so we should absolutely expect a steep learning curve, and yeah, probably a few explosions before they lock it in. But once they do, 2 years later, a colonial fleet of 20 Starships arrives, dropping off 75 tons of vital infrastructure. And all of this sets the stage for the year 2030, when the very first human crews finally arrive.
But where exactly is this robotic vanguard touching down? Well, SpaceX has targeted a prime candidate called the Arcadia region. It sits just northeast of Olympus Mons, which is the tallest volcano in the entire solar system. The reason they're aiming for this flat plain near the equator is incredibly simple. It contains large, vital deposits of underground water ice. On Mars, water ice is hands down the single most important resource you can possibly find.
Section 3. Manufacturing Martian rocket fuel. Return trip to Earth. Finding that water ice leads us directly to the massive engineering challenge of getting back home. Early colonists are going to want a return trip, but bringing enough heavy rocket fuel from Earth for two-way journey, it's physically impossible. We have to make it there, and this brilliantly illustrates the elegance of SpaceX's plan. They chose methane as the fuel for the Starship, specifically because it can be manufactured entirely using local Martian resources. First, the robots extract that water ice we just talked about. You can split water into oxygen and hydrogen. Second, they pull carbon directly out of the thin Martian air, which is mostly carbon dioxide. Third, they combine 1 carbon atom with 4 hydrogen atoms to create stable methane fuel. And, as a vital byproduct of this exact same process, they produce breathable oxygen for the colonists. It's just an incredible closed-loop industrial process. To actually get to that ice, the robotic vanguard will rely on scaled-down Martian mining rigs.
utilizing tunneling technology from SpaceX's sister boring company. The beauty here is that as they dig for ice, all that excess rock and soil can be processed into a kind of asphalt to lay down roads and landing pads for future ships. But, getting this water treatment and mining plant up and running takes time. Until that water plant works flawlessly, early colonists might literally be relying on completely recycled water. Yep, turning last night's pee into this morning's coffee.
Section 4. Building the first habitats. Shelter on Mars. So, let's fast forward to the year 2030. Our mining rigs and fuel plants are taking shape, and 100 starships touch down with the first human settlers. Their immediate need, reliable power and shelter from those harsh elements. When they step out, they are not moving into sprawling glass cities right away. The short-term shelter will actually be the Starship landers themselves. They're gigantic and provide adequate life support, sure, but they are tall, narrow, and require taking an elevator just to get in or out, which makes them pretty awkward long-term homes. What's crucial here is surviving the night. Mars days are almost the exact same length as Earth days, and when the sun goes down, it gets freezing, and solar panels obviously stop working. So to keep these temporary Starship homes alive, colonists will use massive battery systems. Think Tesla megapacks, to store enough energy to survive the 12-hour freezing Martian night. To build permanent shelter, you can forget about those sci-fi glass domes. They're way too heavy and incredibly hard to build. Instead, NASA and other engineers are looking at something called the ice dome. Here is how it works. First, you deploy an inflatable donut-shaped module shipped from Earth. Then, a solid mold goes up around the base. Finally, autonomous robots fill that mold with locally sourced Martian water ice. It acts perfectly as a natural insulator, kind of like historic Inuit igloos here on Earth. But even more importantly, a thick layer of water is one of the absolute best shields against the deadly solar radiation constantly raining down on the Martian surface. But what if you need larger structures, like factories or labs? For that, you need something like concrete. Since we obviously can't ship thousands of tons of cement from Earth, scientists have developed a wild concept called astrocrete, or biocrete. This is a highly durable concrete formed by binding the abundant Martian rock and soil with urea, which is a waste product filtered directly out of human urine. I know, there is a definite EU factor here for sure, but it's incredibly practical. In fact, medieval stonemasons used to mix animal blood into their mortar to make castles stronger, so using bodily fluids as a building binder isn't even a new concept. It's really just the ultimate frontier recycling. Section 5. Farming on toxic soil. Growing Martian food. All right, so we have power, water, fuel, and shelter. That brings us to the final and arguably most difficult hurdle: feeding 1 million people on a dead planet. To do that, we have to understand just how hostile the ground itself is. Martian soil isn't just dead, it's actively toxic. It's laced with compounds called perchlorates. Now, what's really interesting about this slide is that these are toxic chlorine-based chemicals, essentially the exact same stuff we put in swimming pools to stop bacteria from growing. So if you try to just plant a seed in untreated Martian dirt, the perchlorates will immediately kill it. This leaves us with a few very tough agricultural choices. First, we could transport clean soil from Earth, but let's be real, even a whole starship full of dirt isn't going to feed 1 million people. The real solution requires building an entirely new industry on Mars to process the native soil, essentially washing out those toxic perchlorates. But here's the catch. Even clean Mars soil lacks the nutrients that plants need to thrive. So how do we fertilize it? Well, if urine is making our cement, you guessed it, human feces, good old number 2, will be the ultimate fertilizer used to grow the crops for the masses. As they say, no one ever promised colonizing Mars was going to be glamorous, but it absolutely demands total resourcefulness. Let's review this final checklist. Through incredible ingenuity, autonomous robots, and extreme recycling, we really can secure the basic necessities of life independently from Earth. We secure power through solar and massive battery packs, we mine water from underground ice, we extract oxygen and rocket fuel from that water and air, we build shelter using ice and astrocrete, and we conquer the toxic soil to grow our own food. By locking down these pillars of survival without relying on a constant umbilical cord to Earth, we truly cement our future as a multi-planet species. Which leaves us with one final, incredible thought to ponder. We've seen the blueprint, we've walked through the timelines, and we've looked at the brilliant engineering required to turn a deadly, freezing desert into humanity's second home. Make no mistake, it will take everything we have. But if we can successfully engineer a self-sustaining city in a toxic, freezing wasteland like Mars, where do we go next? Thanks so much for joining me on this explainer.
I really hope it sparked your curiosity as much as it did mine. Keep learning, and I'll catch you next time.